Now this question illustrates concepts of common ion effect. Question says, what is the pH of a solution made by adding 0.3 mole of acetic acid and 0.3 mole of sodium acetate to enough water to make 1 liter of solution? So we have been given mole of acetic acid, sodium acetate, and the volume of solution that is also given 1 liter. So mole of acetic acid, this is 0.3 mole. Since volume is 1 liter, so concentration of acetic acid, this is mole by volume, so this is 0.3 m. Now acetate ion, that is given 0.3 mole, that is sodium acetate, so sodium acetate concentration will be again 0.3 divided by 1, so this is 0.3 m. Now acetic acid is a weak acid, it will dissociate and its solution it will give CH3COO minus H plus. Now it is given initial concentration of CH3COH is 0.3 m and initial concentration of CH3CO minus, that is also 0.3 m. Because this is a strong electrolyte, this will dissociate into CH3CO minus and Na plus. So from here we will have concentration of CH3COO minus, that is 0.3 m, and concentration of Na plus, that is also 0.3 m. This is because this is a strong electrolyte, it will dissociate 100%. So concentration of CH3CO minus initially, that is 0.3 m, and there is no H plus initially. Let us say this is at time t is equals to 0. After some time, that is equilibrium, we will have some mole of acetic acid dissociated. Since 1 mole dissociate and it forms 1 mole, so here we have 0.3 plus x, and we also have 1 mole, so here we have x. Now we can write expression for equilibrium constant Ka. K is concentration of H plus into concentration of CH3CO minus, and this divided by concentration of acetic acid. Now this is x, this is 0.3 plus x, and this is 0.3 minus x. Now to solve this equation, we will make two assumptions. And what are the assumptions we are going to make? First assumption is, since acetic acid is a weak acid, very few concentration of CH3CO minus that will come from acetic acid. So mainly acetate ion will come from sodium acetate. So I can say first assumption is mainly acetate ion will come into the solution from sodium acetate, that is the salt. So if I assume this assumption, total is 0.3 plus x, so I can say mainly it is coming from sodium acetate, so x is negligible compared to 0.3, so we can write 0.3 plus x. This is approximately equals to 0.3. Now the second assumption I will make, that acetic acid is a weak acid, so dissociation of acetic acid is very less, that is x is very small compared to 0.3. So acetic acid is a weak acid, and its dissociation will be very less. That is, I can write 0.3 minus x is approximately equals to 0.3. Now if I put this value to assumption in Ka, so we have Ka is equals to x into 0.3 plus x, this divided by 0.3 minus x. You see here that is 0.3 plus x divided by 0.3 minus x. Now we have assumption that is 0.3 is equals to 0.3, so x I can ignore, and in the denominator we will have 0.3. So we have k is equals to x, and k is given, that is 1.8 into 10 to the power minus 5 for acetic acid. So this value is 1.8 into 10 to the power minus 5. So x is 1.8 into 10 to the power minus 5. Now we can check the assumption, x is 10 to the power minus 5, order is 10 to the power minus 5, and this is 0.3 is 10 to the power minus 1. So this is true that we can always ignore x with respect to 0.3. In this case also we can ignore 1.8 into 10 power minus 5 compared to 0.3. So my assumption is basically okay. So it is always advisable to check the assumption, that is 0.3 plus 1.8 into 10 to the power minus 5 is approximately equals to 0.3. Another assumption we have 0.3 minus 1.8 into 10 to the power minus 5, this is again equals to 0.3, and x is nothing but H plus. So now I know the concentration of H plus, that is 1.8 into 10 to the power minus 5. So we can calculate log H plus, that is log of 1.8 into 10 to the power minus 5. So I can take log so this is minus 4.74. If I take minus both sides, so minus log of H plus, this is 4.75, or that is 4.74. So we will have this side pH, so pH is 4.74.